Assalamu alaikum. Hello everybody. This is new video about differentiable function. The first question or exercise, let f be a differentiable function at 0 such that f of 0 equal to 0 for all k in n natural number. Find the limit of 1 over x, f of x plus f of x over 2 plus f of x over 3 plus that plus f of x over k. K is a fixed natural number. Find the limit when x goes to 0. The second question in the same sense, let f be a function that is differentiable at alpha. Determine the limit of f of alpha plus 1 over n squared plus that f of alpha plus n over n squared, sorry. Let us start by the first exercise or question. So this is a proposed solution. This is very simple and very nice. Since we have f of 0 equal to 0, we will use this hypothesis. We take this expression, we will write it on a adequate form. So we have f of x minus f of 0 equal to 0 over x plus f of x over 2 minus f of 0 over 2 over x over 2. So here we have x, and since we divide by 2, so we take 1 over 2 to cancel that we divided by 2, plus f of x over k minus f of 0 over k. F of 0 over k is actually equal to f0. Just wrote it like this. Actually, we can take here 0. It is more suitable. It is more correct. Over x divided by k, and since we divided by k because originally we have x, so we take 1 over k. When x goes to 0, this goes to f prime of 0. This goes to 1/2 f prime of 0 plus 1 over k f prime of 0. So we have the limit is actually, this goes when x goes to 0, this goes to 1 plus 1/2 plus 1 over k f prime of 0. This is the result, this is the limit. How about the second exercise? The second question or exercise. We have approximately the same idea. It is just more complicated than the first one. Here what we can write. Our function is here minus the limit minus n f of alpha. Minus n f of alpha. This is the question. Yeah, I think that this is the question. What we can do here, we can manage this. So we can manage this by writing it as f of alpha f of alpha plus 1 over n squared minus f of alpha plus f of alpha plus 2 over n squared minus f of alpha plus the last one f of alpha plus n over n squared minus f of alpha. We can write this as this is equal to the sum from k equal 1 to n f of alpha plus k over n squared minus f of alpha. So if we take the sum from k equal 1 to n, we will get here minus n f of alpha, and k from 1 to n, here we will get f of alpha plus 1 over n squared, and so on. So we have the same formula. Let us focus on just this formula. I think that now I can clean the whiteboard here to use this area. Let us focus on this one. F alpha plus k over n squared minus f of alpha since f is differentiable at alpha, so here we can write divided by k n squared, and with times here by k over n squared. So this is the same result. I mean f of alpha plus k over n squared minus f of alpha, this is equal to k over n squared. Exactly the same thing. Let us focus on this expression. When n goes to plus infinity, this is the derivative. So there exists n0 from n, such that for all n greater than or equal n0, one has what we have. We have here, I will write it here, we have f of alpha plus k over n squared minus f of alpha over k n squared. This is less than f prime of alpha plus epsilon or equal, and greater than or equal to f prime of alpha minus epsilon. Why? Because this is the derivative, since f is differentiable at alpha. So when n goes to plus infinity, this goes to f prime of alpha. This means that there is a rank, that after this rank we will have this formula. But if we times by k over n squared, so we get here k over n squared, we get here minus k epsilon over n squared. So we get this formula, k over n squared and k over n squared. We have the sum from k equal to 0 until n. So we will take this sum. If we take the sum, this is here alpha plus k over n squared minus f of alpha. If we take the sum, from this side we get f prime of alpha n squared, and we sum k from 1 to n. This gives us n plus 1 over 2, because if we take the sum from k equal 1 to n, this is equal to n times n plus 1 over 2. This is well-known formula, minus n plus 1 over 2n squared epsilon, less than this sum, which is our limit, the limit that is concerned by the calculation. From this side we get n plus 1 over 2n squared f prime of alpha plus n plus 1 epsilon over 2n squared. This is the formula. When n goes to plus infinity, here we have the sum for sure, so we have n plus 1 over 2n squared. When n goes to plus infinity, this goes to 1. Here we have, I forget it, I repeat it twice. This goes to f prime of alpha over 2 minus epsilon over 2, less than or equal the limit, our limit, less than or equal to 1 over 2 f prime of alpha minus epsilon over 2. This means that the question, the limit of this sum goes to f prime of alpha over 2. This is the answer of this question. I will check the time. I will just check the time. It's okay. I think that I can add a question. Let f be a function. Let f be a differentiable function. Differentiable function at x equal 1 with f of 1 equal to 1. Calculate the limit of the function n, to be sure from the question, and f of 1 plus 1 over n plus f of 1 plus 2 over n. This is the question, plus f of 1 plus k over n minus k. This is exactly when n goes to plus infinity. So this is the limit when n goes to plus infinity. This is a little bit as the previous question. It's a little bit different. What we can do here, we take just this one. We take just this one. We will write it in this form. Minus k, we can write it as minus k f of 1, because f of 1 is equal to 1. Then we transform this formula to n f of 1 plus 1 over n minus f of 1 plus f of 1 plus 2 over n minus f of 1 over 2 over n. here we divide by 1 over n. So this formula, take this form. Here we have 2 over 1n, so we take here 1 over 2. Now we have here 2 to cancel with this one, plus 3 f of 1 plus 3 over 2 minus f of 1 over 3 over n, plus the last one, we have k f of 1 plus k over n minus f of 1 over k over n. When n goes to plus infinity, this goes to f prime of 1, this goes to f prime of 1, and so on. So we get f prime of 1 times 1 plus 2 plus k. And this will be equal to k times k plus 1 over 2 f prime of what? F prime of 1. These are 3 questions from the same kind, using sum, limit, and the fact that the function is differentiable at a given point. This is all for this video. Hope that we will meet the next time with a new video, inshallah.